All right, I had started this problem a moment ago, and then I had to delete my video because I messed something up. Anyhow, you want to rent a limousine for a trip to the city. The limo costs $700 for the night and 15 cents a mile. So you know right out of the gate that you have to put up your $700, and then you've got an issue about how far. $750 is your maximum. So I started out by setting up an inequality. There you go. You can see it. 700 plus 0.15 m. Now the 15 cents times m is representing how many miles I can drive. Then I went on and I solved my problem, and I started showing my undoing. So it boiled down to I had 15 cents per mile had to be less than or equal to $50 that I had remaining after paying the $700 up front. When I divided both sides by 15 cents, I found out that I can drive the limo at most. Miles have to be less than or equal to 333 1/3. Moving to the relation function area of your test, defining a relation, the basic definition of a relation is a set of input and outputs. Now, when we talk about input and outputs, we really are thinking about our x and y independent and dependent values. A function is more specific. A function is a relation such that each input, so each x has exactly one y. So no x can have more than one different y value. Has exactly one output or y. So no x can have more than one different y value. Now, when we look at deciding if a relation is a function, we're looking at a mapping in this case. And when we look at a mapping, we're looking at all of our inputs to make sure that they only go to 1. Well, I see an issue right out of the gate. When I'm talking about an input of 0, 0 maps to not only -2, but it also maps to 1. So it doesn't have exactly one output, it has 2. So is this a function? No. Now it says explain. You'd like to write it out in words, but I'm not going to take the time to do that right now. Now, number 19 is I'm looking at all my x values, and they all happen to be 2. If I made a list of this, what I would do is take my ordered pairs, and show that 2 goes with -3, 4, and -1. Not a function. Each input x has more than one output. When x is 2, it goes to 3, 4, -1. Not a function. In number 20, my x's are 2 and 6. My y's are 6 and 2. No problem. This is a function. Each of my inputs has exactly one output. Looking down my table for 21, I'm looking at 6 distinct x values. Now notice when I say I have 5 distinct x values. Notice when I say when I have 5 distinct x values, I'm going to stop right there. It doesn't matter what my y values are. No x value has been repeated. This is a function. I just flung my pen cap across my kitchen. Now, number 22 goes on to, I'm going to grab my cap, finding the domain and range, and we're going to do that for problem 19. Well, problem 19 was up here. My domain, oh, that was where the x values were all 2. My domain is 2, and my range is, what do we have? -3, -1, and 4. Remember, brackets need to be used around your domain and range, as well as commas separating your values and no repeats. Number 23, looking for the domain and range in problem 21. I'm going to list my x values. There was no repeats. They're in order. And now I'm going to look at my y values, because they matter as they are the range. Y values, I did have repeats there. The smallest y value is -2. I'm going to look at these values for a minute and order them least to greatest. -0 appeared twice. I'm not writing it twice. I'm only writing it one time. It's showing up as the range has these numbers in it. It doesn't matter to tell how many times. Let's see what we have next here. I'm going to graph 24 and 25 before I stop this video and move on to another segment. In number 24, these are nice. We've got our slope-intercept form. Our y-intercept is where we want to start on the y-axis. Our slope, 1, 2, 3, 4, 5, 6, 7, 1, 2. We want to think about as rise over run and count up and over. In this case, as it was 7 over 2. Oops. Remember to give you rulers on your test, and I'm going to connect and extend that line. I don't have a context to the problem, so I'm not sure that it doesn't include all values. Now in 25, I want to graph this, but I'm looking at the numbers 32, -2, and 8 in this problem, and I realize they're all factors of each other. So I'm going to rearrange this into standard form, and I'm going to do that by adding 2x to both sides. 2x plus 8y. Took this from this side, added it to undo, came up with 32 equals 2x plus 8y. The reason I'm doing this is because this is in standard form, and I'm going to try to figure out real quickly what my x and y intercepts are. That could let me put this on a graph without making any kind of table or solving for y. If I put in 0 for x, I'm going to have 2 times 0, which is 0, so 8 times something is 32. I know that to be 4. When I put in 0 for x, y is 4.